Yeah. So this is this duplicate system? Let's check. So this. So so what we did last time, something like we deployed a yeah. So we deployed a Tomcat container, right? Something like Docker ps -a. Yes. So the Docker is running from up to days, something like this is the Docker container. So I executed as a port, something like history. Will show you. Yeah. So yes. So the container runs with the port 8081 and 8081 and 8080. So something like a Docker run as 8080. So the port is running. The port is running with the sample jar file, right? We deployed a sample jar. So how you can deploy something like a Docker cat Docker will be deploy that file. Yeah, move. So this is the file, new doc file. Docker file. Yeah, this is the Docker file. So something like we are enabling the repository, then install the Java, then create a directory by using mkdir opt tomcat, then work directory opt tomcat, and so download the tomcat and download the tomcat into this code this directory, then unzip the unzip the Apache, then Apache move this file name to this here and work directory opt tomcat web apps. So run call git something like a sample web apps that where is there. So we can download that or something like we need to check with other until tomcat where download. So we can download simple jar or where application sample where data the place sample where into the file download tomcat run where jar simple tomcat sample web app. There is a folders main purchase. This is the variety of places. So this is the application to deploy. We don't need this much big. This is a Eclipse Tomcat sample dynamic web project with Wikia. Download batch out. Let's check this one. This is this BLUJAY. What is Docker? Docker file.
Yes. I'm hearing. No, saying you ever told me how I got it.
Yeah, downloading this file as a sample. Let's check it.
Harry, can you hear me?
Yes, yes, able to hear.
Yeah, in the other page where you have MV and new MV space new my Docker file, was that a command? Because when you created it, cat Docker file, it didn't come with the new Docker file. It only came with Docker file. This my V new Docker file.
New Docker. Yeah. No. So actually, so after your class, I'm taking another class. So that time I changed the Docker file to new Docker file. Just the file is named nothing but a Docker file. So that's the reason I moved from new Docker file to Docker file. Okay. So after your class, I'm changing the Docker file name to new Docker file. So again, again, I reverted it. I changed it to new Docker file to Docker. So Docker file is the a default file for to build our Docker images. Okay.
Mm, okay.
Yeah. Docker ps hyphen a. So these are the two images I want to. So remove these two images. Hmm.
So you are creating an image right now.
Yes. So first I'm
Mm,
it's already images is there. I'm removing the container and I'm removing the container and I'm deleting the images. Then I will try to run this Docker file, build the Docker. Okay.
okay. Okay.
I can use this file to remove Docker. Mm. So Docker rm will include. So it will find then remove. Now you can check Docker pages hyphen e. It's deleted. Now check Docker images. What are the images are there? So these are the three images are there. So we need to delete these three images. How we can delete it? By using the Docker RMI. Or else you can use Docker RMI, image ID, right? So I want to delete forcefully. So hyphen yep, delete this Docker image. You want to you can delete multiple Docker images at a time by using space. By using space, it will delete. Yeah. Now let's check it. Docker images. No, there is no Docker images. So there is no Docker images. Docker images. No. So we can execute the command. What is the command we need to execute it? So we can execute this Docker run Tomcat 8. Let's check it. Directly we can run it. We can create. We can pull, create, and run Docker, right? So something like I'm creating a Docker run ITD port number 80807, something like a Tomcat.
Yeah. So, Harry, please one second again.
Yeah.
When I was reviewing the last class that we had about this Docker, to create the Docker images. So when you want to remove the ID, like the container ID, if you have like two container ID or three on the port part of it, are you, because last one I saw was only 80, the port number. So are you putting the hyphen P80 because it has only one container ID? So when it has two container ID, on this hyphen P, are you going to have 8080?
Yeah.
When do you
Port.
use only hyphen P80 and when do you use hyphen P8080 for complete?
Yeah. So this is the host. So this is
Yeah.
the host. This is the host port. This is the container
Mm,
port. So this is the
okay.
host port. This is the container port. So which port we are enabling? We are enabling 8080 port on this Tomcat 8 container. the Tomcat 8 container with host equal to 8080. If you are not providing anything, so the host port taking, the container port taking, so something like you're providing 80 is the host port and container port, it will take a default, right? So now you check docker ps icon here. So Docker build, right? We need to build that. Yeah. So Docker build also we can use it, or we can, so something like we can use the Docker run command. It will automatically build. It will automatically create. So -d port number 80807, something like a so Tomcat, or else. So if you want to, create a Docker build, I something like you can also create this one also. You can create this one also, something like Docker run IPD port number 8080 my second. So after building your Docker file, so we can run this command also. No, so what I did is something like you can directly create the run the port. You can directly run the port. Let's check the Let's check the type. How can I get the IP address? Can get the IP address through history. Mm, This one command. Yeah, so this is the command. Yes, you can get it the IP. This is the IP. Port number 8080. You see, so this is the Tomcat. Then LE lab 6. Let's check. It's not top found. It's got movies. Or we can use Docker. Let's remove this. Docker images. Docker rm everything. This is the remove the Docker law. Now, how we can build our image? How we can build our image? Something like I'm using this command. I'm using this command. Something like how we can build the command. Docker build. Docker run IPD. IPD 8 port number 8080 colon 8080. Then tag. What is the tag? Second, right? Docker run. It is the Yeah, my second. Yes. Up second. Wait second. Let's check it. It is up. Can what is that? LBA. Yeah. So this is the. So this is the. So this is the Java and Tomcat. So we deployed a Tomcat and we deployed the one web application. We deployed one web application. So this is the image. So this is the image we created. So we created this image by using Docker build command and we deployed on the server. We deployed on the Docker container. Guys, got it? Now you understood? Or else if you want to take
Can you
a
take can you take us one more step on that, please?
so one more.
Yeah, one more step.
Yeah. So what we did is so this is our so VM. In this VM, CentOS is installed. CentOS CentOS 7 is installed. On the CentOS 7, you run the Docker. You run the Docker service or a daemon. Docker service or a daemon. This Docker service, you use the Docker file. Use the Docker file and create the Docker file. And from this Docker file, you create the image. So this is the a Docker image. In this Docker image, you run as a content. So this is the container, Docker container. So Docker container, in this Docker container, so install the CentOS image and Java install and Tomcat install. So Tomcat installed. In this Tomcat, you deploy a code.
So
Code is
this
nothing
is
but
a physical server virtual machine, right?
yes. So you can
Then the Docker container is installed in the physical server as well with the Docker file and Docker image.
yeah. So for example, so this is a physical server, or for example, this is a cloud. So either physical server.
Mhm.
So for example, this is a data center. The same way you can do
Okay.
it. So if it is a data center or if it is a cloud or something like it is a physical server or a VM or something like if it is a EC2 instance, whatever it may be. You can install the Docker daemon, and you can create our Docker own images, and we can push whatever the images, right? We can push this image to in our artifactory. 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 So artifactory is nothing but either Docker Hub or something like a JFrog or something like a Nexus or something like a AWS Artifactory, Code Artifactory, or something like a Azure Artifactory. So you have number of artifactories are there. So whatever you build the images, you can push it to the Docker Hub, then pull it in the content. We can do it. So we can do it either ways also. We can push it also. So we can push the we can push the Docker container also to the Artifactory. So you can push the
So
Docker.
what it means is that when you build it in the image, this precursor, we can push it to the Artifactory and still push it back to the Docker container.
Yeah, we can. So we can push it as the Docker container. Yeah. So I will show you. After creating the images, you can push it to Docker push, right? We have a Docker docs is there, or you can use the any command. I will show you guys now. So Docker push is the command. So Docker push is the command. You can push that Docker to something like whatever the images you build, right? So for example, this is the image. Instructor, duplicate session. Whatever the images you created, so Docker images. So this is your second. My second is the image, right? So how you can push your Docker image, something like Docker push. So Docker push my second. So the name of the what is the name of my Docker? What is the name? Yes, I already wrote somewhere. Hare Krishna. Okay, right. Let's try this. Docker push. Hare Krishna does. Second, my second. Using the tag labels, the push refers to the repository Docker type of which a second, the image does not exist locally with the tag. Yeah, I need to create with the tag. So I need to create with the tag called something like this is. So let me Docker IO. Docker.io slash. Yeah, it's not created the local. It's not created with the local. Yeah, let's create build another example. For example, let's remove everything. Docker and remove those history. Yeah, this is the command. Another. Yeah, deleted right. The Docker for RMI. Delete everything. For Docker images. RMI to remove the images, Docker RMI, image forcefully with image ID. What is the image ID, guys? Is the image ID? Yes. Docker images. There is no Docker images. Docker images, no Docker images. Docker ps. There is no Dockers. So now I'm creating it. So I have a Docker file, right? So this is my Docker file. I want to build it from this Docker file with the registry name. So build, Docker build -t docker.io. So because of I'm downloading from here, right? Or pushing from or pulling. So docker.io. My name is, what is the name? Yes. Krishna. This is my name. So then you can give the name of the example, something like Tomcat. I'm giving Tomcat name. So then let's. So here we know I can check it. Reload. Dot. Missing. So this is my profile. Okay. So there is no repositories. There is no repositories. So started my country. There is no images, right? So next it's created. Image is created. So Docker images. Yeah, Docker images created. Let's push this image. Docker push. Docker push registry.example.com.
Harry, can you show us where you drive this command from at this point where you are? Is that a command? Is that a full command?
Yes, this is right. So what it is, what this is, I will show you. I will show you. Wait. So this is my Docker registry and my Docker registry. This is my name. So this is my login. So this is my Docker registry and my login. So this is the name of the container. So name of the container. I'm pushing this Docker images to my repository. I'm pushing this Docker repository to my repository.
Yes, but does it? Can you show us the
This,
command where you add in?
yeah, you see before there is no our own container, but you should push it to my repository. So I will show you the command. Yeah. So Docker push command, when you create the Docker, when you create the image, when you create the image, so if you want to push this image to your local remote repository, so definitely we need to create with the with the registry name. So this is the how you can log into how you can push this as docker.io. So what is your repository name? Something like what is your repository? So harikrishna.857. This is my repository. So in this repository, so we don't have. So now I have a Tomcat 9. I have a Tomcat 9. I have a Tomcat 9 image is created. I created my own image through the Docker build and I push it to the, I push it to the Docker hub. Now, something like you can create another EC2 instance. You can create another EC2 instance. Then you can pull from from Docker Hub to your local repository, then you can run that command. You can run the command. You understood, guys?
Yes.
Yes, right? So this is the command. This is the command. Or something like we can push. So Docker images. Yeah. So we have a Docker images. So Docker. So I'm removing these images. Docker RMN, Docker RMN, image ID, image ID. Yes, Docker PS. So there is no Docker PS hyphen A. Yeah. So now you can check. For example, this is the new server. So this is the new server. So you are downloading. You are downloading from that Docker Hub registry to. So your image from this Docker Hub registry. How you can download that registry? Docker run -it -d -p port number 8080 colon 8080 slash docker.io slash. So docker.io slash, what is that name? Guys, one second. What is
I
that
think
name?
this is when you want to pull it out from the repository, the
Yes,
artifact
yes,
back to
yes, yes,
the
yes,
physical
yes,
server.
yes. Yeah. So docker.io Hare Krishna Tomcat 9. Okay. Use latest or something like that. So it is downloading from this repository. So there is no images in the local. I just created my Docker images and I push it to the Docker Hub, and I can download it from my Docker Hub repository. Docker PS. Docker PS hyphen. You see, second ago. Let me check with the image ID. Yeah, now it is getting right. It is getting. So it is downloaded from the. So it is downloaded from the repository. It is downloaded from the repository and and deploy it and deploy it. Now you got it. You created your own Docker image. You created your own Docker image. Push it to your Docker. You push it to Docker Hub repository. Docker Hub. So push to. So this is a push. This push. Then you can pull from the Docker Hub repository. You can create your own images, and so then you can deploy it on the container. You can deploy it as a container, or else, so you want to create, you want to push, so you want to deploy these two. Yeah. So these are the new EC2 machines. These are the new EC2 instance. So this is the new EC2 instance. EC2 instance. So this is new EC2 instance. Yeah. So you install the CentOS 7 again, install the CentOS 7, again you install the CentOS 7, again you install the CentOS 7, then so install the Docker daemon or Docker container. Then you download this Docker image from the Docker pull, something like the command is Docker pull command. So then you can run the Docker run. You can run the Docker run. So this is, so it automatically run the Docker images here, these three new instances. So I created a Docker file and you push it to the some other location that images. So this is a Docker image with a Tomcat and deployed image. So this is a Tomcat, Tomcat with your application, LAA, something like that. Right? So this image, this Tomcat image already having a code under. So you see now, so this is the container. This container having something like a 400, 4 or 500 MB, 500 MB, or so it will be a below 1 GB. It will be a below 1 GB container. So this image, so it will deploy it on the all the EC2 instances. So now you got it, guys. Understood the Docker concepts? Guys, understood or not?
Yeah, well, just one single question. What's the difference between this EC2 instance and the Docker container if you're about to deploy from the artifact? So what's
Yes.
different between the two,
Physical.
the container and the EC2 instance?
Yeah. So you understood, right? The difference between physical, the difference between VM, the difference between containerization. So this is physical, then virtualization, then containerization,
Mm.
right? So virtualization
Yes.
and containerization. So tell me what is the difference between these. So tell me what is the difference between how can you tell me what is the difference between with different physical to virtual, virtual to containerization. So this needs a big physical server. So from physical to virtualization, so we will install the any one of the virtualization software. Then we can run as a VMs. Then we can run as a VMs, right? So then we
Mm-hmm.
can run as a
Mm-hmm.
VMs. But in the container, so we can take the one VM, we can take the one VM and we can run the container. So it is simplifying from physical to virtual, virtual to containerization. So this is this much of resources, this much of resources, this much of resources. So this is not taking the resources, just using the size of the container. Then once you stop or start in the container, so it will take the a physical or virtual array or something like EC2 instances or resources. So once you stop this container, so yes, so day before yesterday, I already told you, right? So we can use the one image, we can use one so something like a one VM, and you can run the multiple environments. For example, this is a non-prod environment. This is a production. This is a QA environment. This is a pre-prod environment. So in this VM capacity, we just only one environment we need to run. So this is stopped. This is stopped. Here. Just we run that development environment. Once the development work is done, we have the physical QA environment. Then we stop this one. So after this, these two are completed. In the pre-prod, we need to verify it. So we can verify it on the pre-prod environment. So the cost reduces and the efficiency and the portability, everything will be increased from a physical server to containerization. Got it?
Mm-hmm.
Yes, right? Yeah. So this is just yeah. So this is a Docker. So this is a Docker. But so something like in a mission, in one physical server, something like I deployed a number of containers. I deployed a number of containers. So these many containers, I ran these many containers in this a big server. In this big server. Yeah. So this is the CentOS 7 or something like this is a CentOS 7. Docker is running. Docker daemon is running. So if this is a data center environment or a cloud environment. So whatever it may be. But these many containers, who will manage these containers? Something like sometimes the container having issues, right? Sometimes the container having issues. So how we can restore restore these containers? How we can restore these containers? How we can manage these containers? How we can connect with one each another? Something like we want a database container, we want a app container. Something these need we need a interlink between these two containers. How we can map these containers. So this is a very difficult to problem. This is a difficult to manage, difficult to orchestrate. Docker does not does not manage the containers. Does not manage the containers. We need a solution to manage this, orchestrate this condition. So there is a new concept called as a Docker Swarm. So some point of time, so it is not suitable for the managing these Docker containers. Managing these Docker containers. Same like as a configuration management tool. So which is the suitable for the configuration management tool? So there is a Chef Puppet, but Ansible is the best suitable for the configuration management tools. The same way, for Docker. So Docker company also created the Docker same, but they're having some limitations. A big a big solution called as a big solution called as something like yeah. So the Kuber Kubernetes is the solution. So this is also a container orchestration tool. So container orchestration tool. So this is the best suitable for to managing the containers. Initially, it was developed by the Google. Initially, it was developed by the who developed these containers, Kubernetes container, Google. Google company created this Kubernetes. After this, donated to CCCNF. So I will show you this. Yeah. So introduction to Kubernetes. Introduction to the Kubernetes. So Kubernetes something like a so you see so something like it will manage all these Vault, DITB, Helm, so Postgres, so front end everything will be Dockerized by the container. Something like a container orchestration. So what is that? Docker is a container orchestration. So container orchestration automates the deployment, management, scaling, networking of the containers across the cluster. So it is focused on managing the lifecycle of the container. Enterprise that to deploy and manage the hundreds of thousands of Linux containers and hosts can be benefit from the container orchestration. So container orchestration is used to automate the following task scales. So what is that? Deployment, management, scaling, networking. So something like there is a two solutions from the container orchestration. So one is Docker Swarm and Kubernetes. So why Kubernetes is a popular? So Kubernetes is a very efficient and they have some their benefits I will show you. So config and scheduling the containers. So what is the container orchestration will do? So this is the For example, this is the container. So what it will do, so configure and scheduling the containers. So if you use the Docker, it will not the configuring and scheduling, provisioning and deploying the container. It will also provision the deployment of the container, redundancy and availability also of the container, scaling up or removing the containers to spread application load evenly across the host and infrastructure. Movement of the container from one host to another if there is a shortage of the resources in a host or if your host dies. So allocation of your resources between the containers. External exposure of the service running as a container with the outside world. So load balancing of the service discovery between the containers. Health monitoring also doing. So these are the benefits. These are the services. These are the services are doing in the container orchestration. Is Kubernetes internally internally manages configuring and scheduling the containers, provision and deployment of the container, redundancy and availability of the containers, scaling up or removing the containers, spread application load evenly across the host and the infrastructure. So movement of the container from one host to another host if there is a shortage of the resources of the host is allocation of the resources between the containers. So the external exposure of the service running on a container with the outside of the world. Load balancing of the service discovery between the containers. Health monitoring of the containers and hosts. So Docker SAM versus the Kubernetes. What is the difference between Docker SAM versus Kubernetes? Both Kubernetes and Docker SAM are the important tools are used to deploy containers inside the cluster, but there are uh, subtle differences between the both. So features Kubernetes Docker SAM. So installation and cluster configuration. So installation is complicated, but once it is set up, cluster is very strong. So installation is very simple, but the cluster is not very strong. So GUI is the Kubernetes dashboard. There is no GUI. Docker Swarm, there is no GUI. But Kubernetes having the GUI. Scalability. Highly scalable and scalable fast. Highly scalable, scalable 5 faster than Kubernetes. So this is the advantage in the Docker Swarm. Auto scaling. Kubernetes can do auto scaling. So Docker Swarm cannot do auto scaling. So what we need to auto scale, right? If traffic comes on that application, definitely we need to scale up the another container. That is the big advantage, right? So if the traffic goes down, it will automatically remove the containers. So if traffic comes, it automatically up the scale of the container. So rolling updates, rollback. So rolling updates. You can deploy rolling updates and it does automatic rollbacks. Can deploy rolling updates but not automatic rollbacks. So here we can do the rolling updates and does not rollbacks. So what is rolling updates? So rolling updates is nothing but so container having the two parts. A container having the two something like a service having the two container. So these two containers, the first containers will create, and then you can start the another container. The deployment is another container. So the same way rolling back, rolling backs. How we can do it? We can do it the rolling backs. So data volumes can share storage volumes only with the other container is in the same pod. Can store the storage volumes with any other containers. This is the a drawback, but this is the advantage in the Docker side. What is learning and logging and monitoring? Inbuilt tools are for logging and monitoring. Third-party tools like ELK should be used for the logging and monitoring. So it's already inbuilt feature is there in the Kubernetes. So Kubernetes. What is Kubernetes? A Kubernetes is also known as a K8S. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Something like K. Before S. So before S, after K. How many? 1, 2, 3, 4, 5, 6, 7, 8. So that's the reason K8S. It's also called as a K8S. Kubernetes is also called as a K8S. It's an open source container management tool. So why it is popular? It is a open source container management tool. It provides a container runtime, container orchestration, container-centric infrastructure orchestration, self-healing mechanisms, service discovery, load balancing, and container descaling. So initially developed by the Google for managing the containerized application in the clustered environment, but later it is donated to CNCF. So written in Golang. So it is using Golang. Golang means Google language. So it is a platform designed to completely manage the lifecycle of the containerized application and service using the methods that provides predictability, scalability, and high availability. So Kubernetes certified Kubernetes distributions. So what are the certifications? Yeah, what are the certifications? So cloud managed EKS by AWS, AWS by Microsoft and G. So AWS AKS. So EK is by AWS. EK is by so Elasticsearch Kubernetes service as AWS. AKS Azure Kubernetes service from Microsoft and GKE by Google Kubernetes service. Self-managed OpenShift. OpenShift is from Red Hat and Docker Enterprise. So local dev test microcreators by canonical or minikube. So vanilla Kubernetes, there are core Kubernetes projects are kubeadm, special builds K3m rancher and weight K-time distribution for the edge services. So what are the most famous? These are the famous of them. A Kubernetes cluster. A Kubernetes cluster is a set of physical or a virtual machine. A Kubernetes, a Kubernetes cluster is a set of physical or a virtual machines and other infrastructure resourcing that are needed to run your containerized applications. Each machine is in the Kubernetes cluster is called as a node. Kubernetes cluster is called as a node. Something like it is a master node and it is a worker node. A Kubernetes cluster is a set of physical or virtual machines and another infrastructure resources. What is a cluster? Cluster is nothing but a set of physical or virtual machines. So there are two types of node in each Kubernetes cluster, master node and worker node. So master node hosts in the Kubernetes control plane components and messages to the clusters. So runs your containerized application in the worker node. Runs your, this is your worker node. So where we deploy our applications in the worker node. So master node will be managing this worker nodes. Managing this worker nodes. Guys, will show you this Kubernetes architecture in the tomorrow. I will show you some of the examples about the Kubernetes. Okay, and I will install how to install the Kubernetes. Will show you the Kubernetes. What is the pod? What is the container? So we'll show you guys tomorrow. We'll show it. Okay.
Okay, can you show us how to get this in case if you want to read it theoretically, the one you just showed us now?
Yeah, I already shared it in the drive.
One more thing that I wanted to ask. Please, there is a file that contains all the commands. Last time, like the yum, like when you want to start the Docker, some of those like the Docker file, Docker commands, everything that has a long note. You showed it on Word document. The one you showed on the Word document.
This is right.
Yeah, this one. Yeah. Where did you save it?
I will post it in the.
Can you copy? Is it possible to copy and paste on WhatsApp?
Yeah, I will paste it in the WhatsApp. You can find it.
Okay.
Okay.
Thank you. Thank you.
I
Thank you.
pasted.
So yeah, thank you. So if you go back to the chat, you remember I asked you a question about port, the 80. I know I'm just trying to get it right because can you just read the chat? There's a question I asked on the chat because some has -80. So is that what shows up on the
You
when
want
you
this
try
chat
to?
also?
No, did you see the chat? I just sent a message in the chat. Can you read my chat? There's a message I sent out in the chat.
My question is that I came across this in the last class. Docker on hyperdating ATP. My question is when do you use icon P to iterate and the only 84? I already told you, right? So if you use the iPhone P port, mm, Docker run iPhone IT, iPhone D is nothing but a detached mode, iPhone P, so 80. Something like, for example, if you give 80, so this is the host node. If you are not providing anything to the -p is the port. So this port is related to host or server port. This port is related to container port. So this port is related to container port. So this is related to your VM. VM. So VM also need to to the VM virtual machine IP address. Virtual machine IP address will go to, so enable this. So if you want to enable that, if you are not using this empty, it will take anything. So in between 1 to 65535, it will take 65535 any one of the port. For example, it is taking 3227. So if you want to see your Tomcat server in the browser, so the IP address of the server, then you can use the port number 3227. So this is the container port. This is the host port. This is the host port. So if you are not providing any port in the container port, it will take automatically default. So if you use this, so you just specified the host port number. You are not specified the container port number. It automatically take. It automatically take. For example, if this is the port number of, so 80 is the port number of which port number, guys? 80 is the port number of. So the default HTTP port number is 80. So the default port number for HTTP is 443. 443. So I don't want to use the default ones. I want to use my own port. For example, for HTTP, you use the 8080. So 8080 is you created your own port. You created your own port for HTTP. So what is 8080 means? So you enabled both the VM port and container ports are the both. You are specifying this VM port and container port. Now you understood?
Okay. So in this case, even
So
if
for
you
example,
have
you can
container
use
ID, if you have
9090
to, if you have to,
90.
if you have to container ID and two Docker, I mean, the two Docker image and the container ID, can you still have this HTTP A0? Does it have anything that affects the number of port number? For example, you
These are
have
the
three
these are the
container number.
default ports. These are the default ports for the HTTP and HTTPS. So I don't use the
Okay,
default port. I
so
use the my own ports.
okay, so whichever one you use, it depends on what you appear is
Yeah.
what you
So
can
in the
use.
real time, you are using
Okay,
your own ports there. Yeah. In the real time, you are using your own ports.
okay,
Okay.
okay. Thank
So
you.
yeah, yeah, good, right?
Yeah,
So
got it.
yeah, so we'll continue from tomorrow the Kubernetes, guys. We'll show it on the Kubernetes. Now you understood, right? So
Yeah.
Docker. So this is the physical, something like this is the VM. This is the container. So how we can orchestrate this container by using Kubernetes. By using Kubernetes, we can orchestrate the container. So for example, in the music group on something like so music orchestrator, right? So he is the music orchestrator. So this troupe is playing. So he is the organizer. So he is sending the instructions to which instrument need to play at what time, right? So this is the orchestrator job. The same way Kubernetes also act as a orchestrator. So these are something like, for example, these are the containers. So which container needs to enable, which container need to connect, which container need to open, which container need to deploy, which container if something goes wrong on the container. So we can scale up, scale down, networking, everything will be taken care by the this orchestrator. Who is this orchestrator? Kubernetes is the orchestrator. Do you understood, guys?
Yeah, what happened if all of them got affected?
If all of them have, yeah, that is the reason. So in the physical server, in the physical, so something like this is the physical server. You deployed your application, WhatsApp application in the physical server. So for a physical hardware, definitely will crash it, right? So what is the solution to resolve this? Definitely, again, we need to put a new server, and then we can build it, we can deploy it. It will take a time, or else something like a VM. VM, we are taking the backup of the VM, snapshot of the VM, then we can restore it, then we can deploy, right? So it will also take time to restore the applications. This is the physical, this is the virtualization, and the containerization. So containerization also something like, for example, this is the server. So this is the VM. So you deployed a container, you get deployed a container in this server. If something goes wrong on, so there is no restore. So if you use the Kubernetes, if you use the Kubernetes in the EC2 instance, so if something goes wrong on the EC2 instance, it will automatically create another EC2 instance. It
But
automatically
this
create
one,
another instance. It automatically creates a pods also. So because of there is a configuration file is there in the master node. There is a configuration
mm,
file is there. So it automatically, if something goes wrong, it automatically spin up the another EC2 instance and the another pod the related pods. That is the beauty of the
okay,
Kubernetes. Okay.
okay,
So the
yeah,
redundancy is faster, scaling, everything will be faster. So the here we need a manpower to verify the which container is running, which container is stopping. But here, so this is the automation. So this is the automation, auto healing. There is a auto healing concept. So it automatically manages their own Kubernetes service in the containers. It automatically manages. So if something goes wrong, and so if for container is crashes, it automatically create another container. So with their configuration file, because of the configuration file is there. So if something like EC2 instance is down, it automatically create another EC2 instance. And what are the pods are there in the EC2 instance? So it will automatically deploy the containers. So this is the beauty of the Kubernetes, guys. So we'll discuss tomorrow. Okay?
okay, yeah, thank you.
Yeah. Yeah. Thank you, guys. Thank you so much.